Okay. And here's just some more terminology. Capital F of x is called the dividend, okay? Capital F of x is the dividend. Okay? That's what that is. Capital D of x, does it matter? Someone had a question? Well, I said that already, that I'm hoping to get it done sometime by next week. Someone asked, when can we see exam 2? Again, I'm hoping to get it posted sometime next week. So I'm doing, the best I can now. So, okay. All right. Good question. Okay. All right. So we have f of x is called the dividend here. D of x is the divisor. Q of x is called the quotient. And R of x is the remainder. Okay? So again, f of x is the dividend. D of x is the divisor. This is just terminology now. Q of x is the quotient. R of x is the remainder. Okay? So that's what we have here. Okay? Again, this is polynomial long division. Okay? Now, again, in the past, what I've done is I would go through synthetic division, but here I want to do polynomial long division. Okay? I mean, from my experience, past experiences teaching this course illustrate that most students have seen it before, polynomial long division, so I figured it'd be good. Okay? All right, so let me go through that. So again, let's suppose we have f of x over d of x, right? We want to figure out this quotient. We want to find q and r, in other words, so that we can do this or this. So it's really just like with it's just like with long division of numbers. First what you want to do is you want to write it like this, where again, d of x is the divisor, f of x is the dividend. And actually what I did was I used this website in case you wanted to see it for the notes. It's actually, I think, a community college, if I remember correctly. But there is a process to doing long division. I did write it out here. We will see some examples. Okay, we will see some examples. Basically here, you want to make sure each polynomial is written in standard form. Use zeros to fill in the missing terms for both polynomials. It's just like what we did when we did addition and subtraction, right? In standard form, that's when the polynomial, the exponents of x, the variable, they're decreasing from left to right. And zeros you use to fill in for the missing terms. Okay? And basically what you're going to do is you're going to divide the leading term of what's in here by the leading term of this. Okay, when you divide, you're dividing monomials, in other words. We've seen how to do that a while ago. The answer you're going to put up here, just like with number long division. You're going to put it actually over its like term, but then you're going to have to multiply and subtract, just like with division of numbers. Basically you're going to multiply, and then whatever you get down here, you subtract it. And then before you subtract, bring down the next term, and then you check if you have to do this again or not. If the degree of the difference is less than the degree of the divisor, then you stop, or if you get 0. Okay? So basically you subtract. If whatever you get down here, the degree is less than the degree of d, or if you get 0, stop, then you're done. Otherwise, you repeat, with the difference down here being the new dividend. Okay, I know this procedure probably sounds a little intimidating, but we will get to it. Again, this is just notationally what's going to happen. Let me just fix that. I don't like that. Move that over. There we go. Now I'm happy. Just wanted to move it over. It wasn't wrong. I just wanted to make it look better. Okay. But again, here we have it. So basically, this is what's going to happen with polynomial long division. You do a bunch of steps. This is your d of x. Your f of x is in here. Dividend, divisor. Q of x up here is your quotient. And this is r of x, what's left over, the remainder. Okay. All right. Okay, now some of these problems can be a little long, but again, we'll go through them. Okay. So again, that's the notation. Okay, I went too fast. But again, when you're done, you want to write it in either this notation, or you can write it like this. They're both equivalent, so. Okay. All right, there we go. So let's suppose, for instance, capital f of x is that polynomial, that cubic, 9x cubed plus 9x squared minus 2x plus 5. The dividend, no, excuse me, that is the dividend. The divisor here, 3x squared plus 5x minus 1. Now notice that they're both in standard form. That's good. And again, that's when, as you read the polynomial from left to right, the exponents, the powers of x, are decreasing. And notice also that there are no missing terms, right? You have x cubed, x squared, x, constant term. You have x squared, x, constant term. So in other words, you don't have to put 0 in as a placeholder, so to say. Or excuse me, as a, well, yeah, placeholder. All right, so what do? As in the procedure, we divide the leading term of the dividend, the 9x cubed, we divide it by the leading term of the divisor, as I'm doing down here. So we have 9x cubed over 3x squared. Doing so, 9 over 3, that's 3. X cubed over x squared. Remember, you subtract the exponents, you get x to the first, which is just x. If you wrote x to the first here, that's fine. I'm not going to take, I'm not going to take points off. I mean, people generally don't write the 1 when 1 is the exponent, but if you do, that's okay. Now, notice also where I put it. I put it over the like term of the dividend, right? That's actually one of the steps here, if I remember correctly. Oh, right here, step 2. You put the answer above the dividend over its like term. Okay. So we have this so far. Now, what do we do next? The 3x, we're going to multiply the 3x with all this, and then we subtract. So again, 3x times all this, right? When you multiply it, you're going to get 9x cubed. 3x times 5x, that's 15x squared. 3x times 1 is just 3x. We have a minus there. And we're subtracting it. Now, the next step here I thought would be easier. What I did was I took the minus, I distributed. So I changed it to addition, and then I distributed the minus. I mean, really, as long as you're subtracting, that's what matters in this step. Because now you can see the 9x cubes are gone. They cancel. You have 9x squared minus 15x plus negative 15x squared, which is minus 6x squared, minus 2x plus 3x, that's x. Notice I brought down the next term as well. I brought down the 5. Okay. Now, we have that. Okay. So now, notice the degree of this difference equals the degree of the divisor. Okay, so we have to repeat the process. You stop once you either get 0 or the degree of this difference is less than the degree of the divisor. So we have to do the process again. But now this is our new dividend. Excuse me, this is our new, no, that's right. This is our new dividend. So that's right. So what do? We divide the leading term of this here with the leading term of this. That's what's happening here. Negative 6x squared over 3x squared. Well, that's equal to negative 2. Okay, so the negative 2 we put up here over its like term, which is 5. You know, they're like terms. Now it's on the next slide. What do we do next? We're going to multiply, right? Basically, we're going to take this minus 2, multiply it by this, right? And then subtract then. So we have minus 2 times all this. And then we subtract. That's what I'm doing here, as you can see. Now, okay, so again, this is something I did. What I like to do is I like to distribute the negative here and change it into addition. That's what I did here. So if you distribute the negative, you have negative, negative, which is plus. Negative, negative becomes a plus. Negative plus becomes a negative. And I add the results. That's what I do. This addition here, this here plus sign, this is addition. Okay, is that going to help us? Well, the 6x squares, right? You have minus 6x squared, 6x squared. They cancel. You have x and 10x. That's 11x. 5 minus 2 is 3. Now, do we stop here? Well, yes, we do. Now, why is that? The degree of this difference is now less than the degree of the divisor. Right? This is degree 2. This is degree 1. This degree is less than the degree of this. So we stop. Let me just, beautiful. Let me just stop.